Hello everyone, in this video let us solve some problems of exercise 1, that is 1.13, 1.14, 1.15. Okay, so this is the question. The charge entering the positive terminal of an element is Q is equal to 10 sine 4 pi t millicoulomb, while the voltage across the element, okay, that is V is equal to 2 cos 4 pi t V, that is voltage. Find the power delivered to the element at t is equal to 0.3 seconds, and the second one is calculate the energy delivered to the element between 0 and 0.6 seconds. So we know the formula for the current. So to find the power, P is equal to V into I, right? So to find the power, we already know the voltage, expression for the voltage, and I is nothing but it is a current. What this current is? It is a rate of change of charge, that is dq by dt, because from this expression we can see that the charge q, okay, it is dependent on the time. So dq by dt means now what I will do, I will differentiate the charge with respect to time. So that is d by dt of, substitute the expression of the charge, that is 10 sine 4 pi t. Okay, that is millicoulomb. Here I will write into 10 to the power of minus 3. So this is 10 as it is. What is the differentiation of sign? It is cos, and here inside it is 4 pi t. So the differentiation of that will be 4 pi, and here it is 10 to the power of minus 3 ampere, milliampere. This is the expression for current. So now P is equal to V into I. What I can do? I can write the expression for the voltage 2 cos 4 pi t into I is nothing but 10 into 4 is 40 pi. Okay, 40 pi cos 4 pi t into 10 to the power of minus 3. So this is 2 into 40 is 80 pi cos square 4 pi t into 10 to the power of minus 3 watts. Okay, so this is the expression for the power. Now to find out what is the power which is delivered to the element at t is equal to 0.3 seconds, here you are going to substitute 0.3 instead of t. So power at 0.3 seconds, 80 pi cos square 4 pi 0.3 into 10 to the power of minus 3. So write this value, this is 1.2 pi, right? Cos square 1.2 pi. So here we can say cos of 1.2 into pi, or what I can write is 1.2 into 180 degree. Pi means 180 degree. I will convert it into degrees to 16. So what is the value of cos 216? It is minus 0.809. If I take the square of that, I will be getting 0.654. Okay, 0.654. So this value is 0.654 into 80 pi into 80 into pi. Okay, where is pi? Here. So this will be 164.495. 164.495 milliwatts. Okay, so this is the answer to this particular question. Next is B. Calculate the energy delivered to the element between 0 and 0.6 seconds. So power is nothing but dW by dt, or this one work is also, we can write it as energy, dE by dt. So E will be equal to integration of T naught to T power dt, right? So here between 0 and 0.6 seconds means I can write 0 to 0.6. What is the value of the power? So that is 80 pi into 10 to the power of minus 3 cos square 4 pi t dt. Okay, so now what is this cos square? So cos square theta is equal to cos 2 theta plus 1 divided by 2. So here I can write as it is 80 pi into 10 to the power of minus 3 into 1 by 2, 1 plus cos 8 pi t dt. Okay, so this is 40 pi, it comes outside, 40 pi into 10 to the power of minus 3, again 0 to 0.6, Here I can write 1 plus cos 8 pi t dt. So taking that this side 40 pi into 10 to the power of minus 3. And what is this 1? 1 is nothing but the t, and here it is 0.6 to 0 plus what is integration of cos? It is sine, right? Sine 8 pi t divided by 8 pi. Here it is 0.6 and 0. So this is 40 pi into 10 to the power of minus 3. This is 0.6. Sine 0 will be 0 only. So this is sine 8 pi into 0.6. 8 pi into 0.6 divided by 8 pi. So now substitute this value. 8 pi into 0.6. Sine, this is 0.587, okay, that is divided by 8 into pi, that will give you 0.023, okay, 0.023. 0.023 plus 0.6 is 0.023 plus 0.6, that is equal to 0.623 into 40 pi into 10 to the power of minus 3. Okay, so here this one into, sorry, 1 second, 0.623 into 40 into pi 78, 78.28 into 10 to the power of minus 3. This is the energy. So now let us see the next question. The voltage V across the device and the current I through each R. So this is the voltage, this is the current. What is the total charge in the device at t is equal to 1 seconds? We know I is equal to dq by dt. And what is q? It is integration of I into dt. Okay, so in the device at t is equal to 1 second means we have to find out till 0 to 1. So this is 0 to 1. What is I? It is 10, 1 minus e to the power of minus 0.5 t dt. This is the integration, right? So 10 outside, integration of 0 to 1, 1 minus integration of 0 to 1 e to the power of minus 0.5 t dt. So this is 10 and this is t, okay? Integration of a constant is t. So it is 1 only minus e to the power of minus 0.5 t divided by minus 0.5. So this becomes plus this one, 1, 0. Okay, so here this is 10, 10, again 1. Next you have plus e to the power of minus 0.5, e to the power of minus 0.5 divided by 0.5. Next here it becomes minus 1 divided by 0.5. So this is minus 2, right? 10, 1 minus 2 plus e to the power of minus 0.5 divided by 0.5. So this is 10 minus 1 plus e to the power of minus 0.5 divided by 0.5 minus 0.5. So that is minus 0.5 e to the power means this one divided by 0.5. Then you have minus 1 into 10. Okay, so that gives you 2.13 coulombs. So answer is 2.13 coulombs. So next let us see what is the power consumed by the device at t is equal to 1 seconds. So what is the power? It is V into I. So we can write this P is equal to V into I. So here what is the expression? Let me take the expressions to that side. Okay, so here power is equal to V into I. So what is this? 5 cos 2t into what is I? 10, 1 minus e to the power of minus 0.5 t. So this is 5 tens of 50 cos 2t. Then you have 1 minus e to the power of minus 0.5 t. So this is the power. So power, they are asking you power consumed by the device at t is equal to 1 second. Okay, so that is 50 cos 2 1 minus e to the power of minus 0.5. So cos 2 means obviously that should be in the radians. So first let me solve this. Minus 0.5, okay, e to the power, so minus 0.5 e to the power, okay, so that is e to the power of minus 0.5, that is 0.6065. So this is 1 minus 0.6065. So after this I am going to write minus 1, so that is 0.393. 0.393 into cos 2, that should be in the radians, right? Cos 0.393 into 2, that is cos 2, that is minus 0.416. Next it is into 50, right? Into 50. So that is minus 8.177. Minus 8.177 watts. This is the power at t is equal to 1 seconds. T is equal to 1 seconds. Okay. Next, let us solve this question. The current entering the positive terminal of a device is I of t is equal to 3 e to the power of minus 2t amperes, and the voltage across the device is 5 di by dt. So this is dependent upon the current. So now we have to find it out. D by dt, what is the current? It is 3 e to the power of minus 2t. So 5 into 3 e to the power of minus 2t into minus 2. So 5 3 is a 15, 15 2 is a 30. So minus 30 e to the power of minus 2t volts. So find the charge delivered to the device between 0 to 2 seconds. So charge is equal to integration from 0 to 2 I of t dt. So this is 0 to 2. What is current? 3 e to the power of minus 2 t dt. Or once again we can find till 0 to 2 seconds. Right? You can find out the expression with respect to t first, and then we can find the charge delivered at t seconds. So this is 3 e to the power of minus 2t divided by minus 2 t and 0. So this I can write minus 1.5 e to the power of minus 2t t and then 0, minus 1.5 e to the power of minus 2t plus 1.5. Okay, so this is the expression 1.5 1 minus e to the power of minus 2t. This is from 0 to 2 seconds, means at t is equal to 2 seconds, what is the charge? 1.5 1 minus e to the power of minus 4. So 1 minus 4 x power. This is the answer. Okay, 1 minus into 1.5. So this is 1.472. 1.472 coulomb. So this is the charge delivered between 0 to 2 seconds. Why did I do like this? If at any point between 0 to 2, if I want to find out the charge between any this one between this 0 and 2, I can use this expression and then I can directly find out the value. But directly if I want to find, see 0 to 2, 3 to the power of minus 2t. So here it is 1.5 minus 1.5 to the power of minus 2t to 0. So this one will be 1.5 minus 1.5 e to the power of minus 4. So this is okay. You can find out the charge between 0 to 2 seconds. This is actually the answer. But why did I find the general expression? If they are asking you to find the charge delivered at some other point, okay, so then we can use the expression. You can substitute the value of t and then you can find out the value. Or else if you want only this portion, directly substitute 0 to 2 and find the answer. Calculate the power absorbed. Power absorbed will be equal to V into I. So what is the expression of V? This is minus 30 e to the power of minus 2t into What is the value of I? It is 3 into e to the power of minus 2t. So here I can write minus 90 e to the power of minus 40. Why e to the power of minus 2t whole square? That will give you e to the power of minus 40. So this is the power. Okay, so this is the power, and determine the energy absorbed in 3 seconds. Energy absorbed in 3 seconds. What is energy? It is integral of power. Integral of power. So in 3 seconds means I'll take 0 to 3. So minus 90 e to the power of minus 40 divided by minus. So minus minus cancels. This is 3 to 0. So what is the value of this? 90 by 4 e to the power of minus 12 minus 90 by 4, and e to the power of 0 is 1. So 90 by 4, okay, 90 by 4 e to the power of minus 12 minus 1, right? So e to the power of minus 12 minus 1 into 90 divided by 4. This is minus 22.5, minus 22.5 joules. So this answer will be minus 22.5 joules. How did you get energy? Energy is integral of power dt, and since I have asked 3 seconds, I can directly substitute 0 to 3, and this will be the answer. P is V into I. They have not asked at any particular point, so we will be finding out the general expression of the power. Okay, so this is all about the exercise 1.13, 14 and 15.